we're just about ready to start simulating, but I noticed this small little thing here. If you look at the corners of our bounding boxes, you can see that they have been cut off somewhat. It looks like their corners are missing. And this is because of our resample node. We did not set this correctly. So let's look at the resample node, and we want to make sure that we tick on resample by polygon edge. And that should fix that issue. Now you can see that we have our corners back. We also want to change our fuse settings. Let's go into the fuse node and just set the distance to 0.01. That looks correct. Let's just look at our final node and make sure that we're not having anything missing. We have complete buildings, no floating faces. That means we're ready to go on. Let's drop down a DOP.NET and a DOP import. And I always color the DOP.NET blue and the DOP import slightly lighter blue. What we can now do is select the DOP import node and then drag and drop the DOP.NET 1 node into the DOP network. That will give us the path that it looks at. And then once we start configuring the DOP.NET, we will also specify the object mask, but for now let's leave it at this asterisk. Before we can configure the simulation, however, we're going to need a few things. Let's just expand our network editor a bit. And let's find our bounding box city block, and that's this one. What we want to do is drop down 2 delete nodes, one after the other, or just copy and paste it. We're then going to wire the bounding box city block into the first delete node and the first delete node into the second. Let's both color them red. Then if we look at the first delete node, we can delete geometry by normal. Let's visualize it, and if we hit space G in the viewport, we should get a good view on our box. What I want to do is delete the top and bottom face. We're not actually extruding a bottom face, but we're just going to build that in as a security measure. So let's expand this bit, and let's look at the normal tab. First turn off the number, enable normal, and then the normal direction is going to be up. And let's look at a spread angle of 45 degrees. And now we should see that we no longer have our top. Then if we visualize the bottom delete node, we want to do the same thing. We want to disable number, enable normal, but in this case we're going to look down. So instead of 1 in Y, we're going to look at -1 and look at a spread angle of 45 again. Now, because we didn't have the bottom face, it's not actually deleting this, but in case we ever change our system so that it does have a bottom face, we still catch that possibility without having to change it again. That's why we're doing this now. So now we've only got the walls left, and we want to drop down a poly extrude to extrude those walls. Poly extrude. Wire that up into the left input, which is geometry for operation. Let's extrude that at a distance of 0.4. That should give us a fairly thick wall. And of course, let's not forget to extrude a back face, because now we have an open inside. So if we scroll down on there, we should see a tick box for output back. We want to tick that, and then we should see that we have complete geometry. This is going to be our bounding box inside the DOP simulation, against which we'll be simulating the buildings. To wrap that bit up, let's drop down another null node. I'm going to color it green as always, and I'm going to call it out underscore bounding box or bbox DOPS. And because we've capitalized out, it's going to show up at the top of our lists once we try and select the SOP. Next, we're going to be building point attractors. What we're going to do is we're going to scatter points along the surface of this box and then move them a bit away from that. Then in the DOP simulation, what we're going to be doing is attracting the buildings towards those points. And as they move towards these points, they will hit the bounding box for the city block and then align to that bounding box. Let's just grab our delete nodes and copy them. This is going to be a second stream. Then underneath there, we want to put down a scatter node. And if we wire that up, we should see that we have a bunch of points scattered along the surface. Now, what might happen this way is that because of our buildings being sat on the floor level, they might start flying, because if they're being attracted by points that are up in Y, we're going to get floating buildings. What we're going to do thus is move all these points to 0. We're going to do that in a fairly simple point VOP. So let's drop down a point VOP, visualize that, and jump inside. We're then going to move this geometry VOP a bit away so we have some space, put down a vector to float, and a float to vector. We're going to plug the P attribute into the first vector to float. X and Z go straight into the float to vector. and then float the vector goes back into position. And now we should see all those points being set at 0. Just because I want to be exact, I'm going to put down a constant. That's going to be the y float, leave it at 0, and just put it in the y attribute. This is just a bit cleaner than leaving it empty. Let's jump back outside. Now if we look at it from the top, we can see that our corners are quite sparse. Of course, I want these points to be as continuous as possible, and the way we can achieve this quite simply is by looking at the scatter node and finding our relax iterations attribute right there. Just want to set it to 0, and that's going to fill those up. Now when we look at this, we can see that our points are set exactly on the surface of our bounding box, and we kind of want those points to be a bit farther out so that the attraction forces will be stronger. And what we can simply do is move these down a bit, and before we scatter, we just put down transform node. And then uniform scale, we can set that to 1.25. And that means that the box where we're scattering on will be bigger. And this is roughly a setting that we want. Maybe move it down to 1.2, find something you like, but you kind of want to have about one building's distance away from that edge. Let's drop down another null node, color it green as always, and call it out_pop attract. So now we have our points that will be attracting the buildings that are inside the block towards the edges, and we have our bounding box that will be holding the buildings back and thus make them align to it. The beauty of this system is as well that once we start automating our system, if we move up and into our city blocks node, if we change the parameter on the blast to say 1 or 2, we can see that we have this block forming as well. So no matter which one we put in, we're still going to have the city block that we have at the time. So for every item we run, this will work correctly. We have the attractors, again, a bit away from the edges, and we have the actual city block. Let's jump back up into the city blocks node, set it back to 0, and go back into our city block sim. This is what we need, and we are now ready to start constructing our DOP simulation. Let's do that in the next clip.